Hello all. In this lecture series, spectroscopy, we have discussed electromagnetic radiation, property of electromagnetic radiation, Beer-Lambert's law, and principles of UV spectroscopy. In this lecture series 5, we discuss about electronic transitions in ultraviolet spectra. So, the transition of electrons always occurs from the ground state of low energy to a higher energy state. You see, this one, energy is increasing on in the lowest level. There is a orbital represented as sigma. And above that, it is represented as phi. In the middle, it is n. And above that, phi star and sigma star. The lowest one we represent as bonding molecular orbital. The highest one, the star, indicates anti-bonding molecular orbital. In the middle n is a non-bonding orbital. Here, the lowest orbital is represented as here LUMO. That means lowest unoccupied molecular orbital. And HOMO, which is highest occupied molecular orbital. So what happens when the ultraviolet light interacts with the molecules? The electrons which is present in lowest unoccupied molecular orbital will get transferred to the highest occupied molecular orbital. That means the atomic orbitals can combine to form a molecular orbital. The atomic orbitals, for example, we can call one atom as one atom having an orbital, another atom having an orbital. And both the atomic orbitals combine together and a new orbital is formed, which we call it as molecular orbital, like H and H combines to form H2. A single H is an atom which has an atomic orbital, and H2 is a molecule, so they have a molecular orbital. So these molecular orbitals will be in two levels. One is bonding molecular orbital, another one is anti-bonding molecular orbitals. So that is what we represent here. Bonding molecular orbital and anti-bonding molecular orbitals. So energy of anti-bonding molecular orbitals will be high and bonding molecular orbital energy will be less. So the overlapping of this atomic orbital will form these molecular orbitals. And the molecular orbitals, we have two types. One is bonding molecular orbital and non-bonding molecular orbitals in the intermediate, and anti-bonding molecular orbitals of a higher energy level. So what happens here? The energy order in electronic state is being represented. The electronic transition that requires the highest energy or sigma to sigma star electronic transition, while the transition requiring the least energy is N to 5 star electronic transition. See the lowest line, the green line at the bottom of the slide, sigma bonding, and for electron can jump from the sigma bonding level to the sigma star antibonding level, which represent a very high energy level. This level is very, very high. So electron jumps from to here. So sigma to sigma star is the highest energy one. And the lowest energy, least energy is N to 5 star. So N to 5 star is next to each other. So energy required for them is very less. So depending upon the compound, whether the compound is having sigma bond, the compound is having a pi bond, or the compound is having a non-bonding electrons, the excitation level of this compound will differ. So based on these differences made by the absorption, we get an output with lambda maximum at a particular region. So by understanding that, we can identify what type of transition that occurs here. So what type of electronic excitation happens in the molecule. So this order is represented here. The energy order of these different types of electronic transition is under sigma to sigma star is greater and m to 5 star will be less. And we get an output in terms of Beer-Lambert's law. Consider that the length of a first sample is low, so absorption is very less. And the length of the container increases, then the absorption becomes less. And the length of the container becomes more, and the absorption becomes more, and the transmission is very low. So the effects of Beer-Lambert's law here is when the L plays a very important role, and concentration also playing a very important role. So based on these overlapping of this the application of Beer-Lambert's law and the electronic excitation levels, the atoms and molecules can be identified by using this ultraviolet spectroscopy. And particularly what type of things is happening, whether the 5 to 5 star transition is happening, whether it is having an aromatic behavior or it is having more number of chromophores can be identified by using this. So thank you. So this principle of spectroscopy is based on these electromagnetic radiations, interactions, Beer-Lambert's law, and the excitation levels. In the next class, we will discuss about the instrumentation of ultraviolet spectroscopy. Thank you.